Welcome to this lesson on polar covalent bonds. In this video, we'll explore a fascinating type of chemical bond where electrons are shared unequally between atoms. This unequal sharing creates special properties that make polar covalent bonds incredibly important in chemistry and in the world around us. So what exactly makes a bond polar? A polar covalent bond forms when two atoms share electrons unequally in a covalent bond. This unequal sharing creates partial charges on each atom. Unlike nonpolar covalent bonds, where electrons are shared equally, polar bonds have one atom pulling the shared electrons closer to itself than the other atom does. Let's compare nonpolar and polar covalent bonds to understand the difference. In nonpolar covalent bonds, we see equal sharing of electrons between identical atoms. For example, in a hydrogen molecule, both hydrogen atoms pull on the electrons with the same strength. In contrast, polar covalent bonds involve unequal sharing, which creates partial charges on the atoms involved. The key concept that determines whether a bond will be polar is electronegativity. Electronegativity is the ability of an atom to attract electrons toward itself in a chemical bond. Different elements have different electronegativities. When two atoms with different electronegativities form a bond, the atom with higher electronegativity pulls the shared electrons closer, creating a polar bond. Here's how polar bonds form. It all starts with a difference in electronegativity between the two atoms forming the bond. When one atom is more electronegative than the other, it attracts the shared electrons more strongly. This leads to an unequal electron distribution, where the electrons spend more time closer to the more electronegative atom. This unequal sharing creates what we call partial charges. The more electronegative atom develops a partial negative charge, represented by the symbol delta minus. The less electronegative atom develops a partial positive charge, represented by delta plus. These are not full charges like in ionic bonds, but rather partial charges that give the molecule special properties. Let's look at some common examples of polar covalent bonds. Water, or H2O, is one of the most important examples. Hydrogen chloride, HCl, is another classic polar molecule. Ammonia, NH3, methanol, CH3OH, hydrogen fluoride, HF, and hydrogen sulfide, H2S, are all molecules that contain polar covalent bonds. Each of these molecules has atoms with different electronegativities bonded together. Why do polar bonds matter? They have profound effects on molecular behavior. Polar bonds enable hydrogen bonding between molecules, which is crucial for many biological processes. They determine solubility in polar solvents like water. Polar bonds affect physical properties such as boiling point and melting point, and they create molecular dipoles and overall molecular polarity, which influences how molecules interact with each other and with their environment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.